All right, the big idea for this question is concept development. We've got an algebraic equation, 3x plus 5 equals 20. Now, for a student that's already kind of proficient with solving algebraic equations, they might do something like this. Subtract 5 on this side of the equation, subtract 5 on the other side of the equation. And the equal sign will stay in the middle. That equals 0. So on this side we have 3x, on this side we have 15. Okay, the next step. Divide this side by 3, divide this side by 3. 3 divided by 3 is 1, so you have 1x, which is just x. 15 divided by 3 is 5. We know that x equals 5. But the question is, how do you get to that level? How do you get to that step? Because in this question, it's about introducing students to the idea of algebraic equations. You wouldn't introduce it this way. This is the goal. That's where you want to get to. First, we have to develop the concept. So what does this problem even mean? So let's take a look at that and how you might do that. It's actually just like we did way back when we were using those part hole mats with the cubes, and I didn't have any, so I was using a cutting board and we were looking at the cubes. So the same exact type of tactile concrete experience you could give to say a kindergarten student who's learning how to count to 10 could also be used for a pre-algebra student or an algebra student who's learning how to get to equations, because you have to develop that concept first. And if you could do it with physical concrete objects, it's going to make a lot more sense before you jump right into the abstract. So let me show you what I'm talking about. All right, so we're back to my magical cutting board here because I don't have a part hole mat, but I do have this cutting board, and I've got these little cubes here. So what we've got is this problem here, 3x plus 5 equals 20. All right, so on this side, each of these post-it notes represents an x. So there's an x, and another x, and this is the plus 5, 1, 2, 3, 4, 5. It has to equal 20. Each of these post-it notes has to have the same amount of cubes on it to equal 20. So for example, I could put 2 cubes in this one, 2 cubes in this one, 2 cubes in this one. But now, does that equal 20? And if you count them all up, it doesn't. We need more cubes. And then the students might eventually figure out if we put 5 cubes on each of these. So now we've got 5 cubes there, plus 5 cubes there, plus 5 cubes there, plus the 5, and that does equal 20. So how much does each of the x's or each of the post-it notes represent? It represents 1, 2, 3, 4, 5. So we know that the x is now equal to 5. So it's the same answer we got by doing it the algebraic way, but again, this way shows the concept. It is the tactile experience and having the concrete manipulatives to kind of move them around, to use guess and check, to visualize exactly what the problem means. So that's the concept development that we want to use to solve this problem. So if you chose the answer that talked about having the mat and actually having the cubes that you can manipulate to show what the problem means, that's the answer we want. Now, from there, again, we've been talking about linkage and how you kind of build upon one thing to the next thing in math. So once you've mastered that idea of using the mat and using the cubes, you might go to the drawing a picture. You might not go right to this just yet. So in the picture, it might be something like this, 3x. So there's an x, plus there's another x, plus there's an x, plus 5. So plus 5 equals 20, equals 20. All right, so in this method, it's going to be some value of x plus that same thing again, plus that same thing again, plus 5 equals 20. And now instead of using the cubes, you could just play around with numbers, and eventually the students are going to find that if this was a 5, and if they were all 5, because they all have to represent the same thing, and then there's 5 more, that does equal 20, that means each of these represents 5, so x must equal 5. So you might go again from the tactile experience of having the concrete manipulatives with the cubes, then you might go to drawing a picture to kind of represent the problem, then eventually you'll get to actually, let's just solve it algebraically because we've already built the concept. But this question was all about how do you build that concept and how do you develop that concept? And you want to develop it in a way that you could visualize and use manipulatives that you can kind of play around with, like the cubes. That's how you build understanding.